Okay, so in today's session, I will be first of all explaining how you can do molecular docking in the easiest way by making use of UCSF Chimera and Autodoc Vina. And to do this, I have come across one research paper that we will just see upon. And in this research paper, it is coming from Nature, and they are talking about D2 dopamine receptor. Okay, so this is a receptor and which is binding to a drug which is called as risperidone. Okay, so we are going to replicate this by making use of D2 dopamine receptor and a drug which is a risperidone. Okay, so first of all, what we need to do is that we are supposed to go and we are supposed to download the tools that we require for performing docking. Okay, so the first tool that we need to perform this docking is called as a UCSF Chimera. So you just go to Google and search for UCSF Chimera. So as soon as you click on this button, it will be taking you to this web page of UCSF. So this is a web page of the software and the developers. So on the left hand side panel, there is a button which is called as a download. So just go to that button, press it once, and you will come to the page from where you can download the software, right? So we are using Ubuntu, which is a Linux platform. So we will choose for this Chimera 1.6 Linux x86-64 bin. So I will just click on it once. So it will bring me to this page where there are different disclaimers, etc., etc. You just read it once and then you need to press this accept button at the bottom. Okay, so as soon as you press this button, what will happen, you are coming to this page and your file is getting downloaded. So this is the first thing that you need to do, that is to download UCSF Chimera. Okay, now in the next step, what you can do is you can go and download. Meanwhile this Chimera is being downloaded, you can go to a web page of Autodoc Vina, or simply say AUTODOC-VINNA. So you just open this page, just write Autodoc Vina on the Google, and you have this first option which is Autodoc Vina. Just go to the download section, or if you want to just read about Autodoc Vina, go over here. So it is taking me to this web page of Autodoc Vina. Okay, so this is basically the algorithm which is being used by UCSF Chimera to perform docking, right? So these are all the features and they are all talking about comparing Autodoc with Vina. Okay, but you just go through it once for your research, and we will be going to this download button to download this tool as well. So as soon as you come to this page, again, as I mentioned earlier, that we are using a Linux system. So we will choose this first option, which is Autodoc Vina .tgz file. So I will just click on it and it is getting downloaded. Okay, so now where are these two files downloaded? I believe that you are the newbies to this Linux system. No problem at all. You just go to this button which is files and you just click on home. Okay, so home, this is the place, and inside this home directory you will get something which is called as downloads. So I will just go over here and I will press on download, and if you see carefully, we have these two files which are over here. The first one is Autodoc and the second one is Chimera, right? So now the first thing that we need to do is to install this Chimera and then to install this Autodoc Vina into the system, right? Okay, so what we will do is we will just, with the help of a mouse, right click button. So what you do is you just do a right click button onto a mouse inside this folder of downloads. Okay, or what else you can do is, rather than just installing it, what you can do, you can just cut these two files from here, go back to home, make a new folder which says bioinfo_softwares. So you just make this folder over here. okay, and you can paste both the files over here. So here we have Chimera installer and the Autodoc Vina installer. So first step that we will do is to install Chimera, and for that you just have to do a one single right click in this folder, right click, and then there is this option, second last option, which says open in a terminal. Okay, so as soon as you click this button, the terminal will be open. Okay, and if you just see carefully in this terminal, I will just zoom it a little so that you can have a better look. I will zoom it more, okay. So if you just see this, you need to have this folder name written over here. Okay, this folder name to be written over here. Okay, so the same folder that we are working, if you can see just on the top of the screen, bioinfo_softwares. Okay, so over here press ls to check whether you have both the files that you need. So yes, you have the first file, which is Autodoc, and the second file, that is Chimera. So first we want to do is to install this Chimera. So the first step or first command that you need to do is to make this installer an executable installer. So you have to write a command which is very simple command. It is chmod space plus x. You just write ch, the initials, and press a tab button on the keyboard. Okay, and then press enter. It looks as if nothing has happened, but if you press ls and check it once, now you see the Chimera is in the green color fonts. Okay, so it is in the green color fonts. Now this file is ready to be installed. So in order to install, you have to just make a very simple command, that is you have to write sudo, then you need to put a full stop or a dot, then a slash, and then you have to write chi, just initials, and press tab, so the entire name of your file will come over here, and then you need to press enter. I need to give my computer password. It may be your computer password if you are doing onto your system. So I will just type my password and hit enter, and it is asking me to install the location. Okay, so anyways, I will just put enter. So it is taking some time. It will be done in a while. I will say yes. Okay, so it is just taking. Let me just check whether it is been done or not. We'll minimize this folder. Okay, so it is trying to install this software. The installation has been going on. We'll wait for a few seconds for the installation to continue. Okay, so here it is saying that installation is done, press return. So I have done, and the installation has been done over here. Let me just check, do I have any option on the screen or not? I don't have any option, so let me check on this this button, and I will just scroll a bit, and then you see UCSF Chimera. Okay, so just let me open it and see. Okay, very nice. So the Chimera is working and it has been installed onto your system. I will close it for a while. Okay, so the Chimera is been installed simply. It is very easy. Okay, now we will go back to our this bioinfo software folder, and we will try to to unzip or unlock this Autodoc Vina, which can be used by Chimera later on. So just double click on it, and what you have to do is simply drag and drop this folder into this bioinfo software. That's it. It is as simple as it could be. Okay, or you can simply press on extract. Okay, so it will say extract, so it will be extracted. Okay, so just close it. That's it. So now you have Autodoc Vina also installed into this place. So now you just need to remember which is this location. So you are going to home. Inside home there is a folder which is called as a bioinfo software. Inside this there is a folder of Autodoc Vina, and inside it again there is a folder of a bin, and inside this bin folder you have this Vina, which will be using it later. Okay, so I will just close this window for a while. Okay, and let us go back to the tool that we were just working on, right? So let us begin with the docking tutorial. So the first we need to go to PDB. So you just type PDB over here and it will open this, go to this PDB homepage, and inside this PDB we need to have a protein, okay, which is a D2 dopamine receptor, and the ID, the PubMed ID, sorry, not PubMed, the PDB ID is 6CM4. So I will just type 6CM4, it will appear at the bottom. I will just click over it once. Okay, so here it is 6CM4, as you can see. Let me zoom a little so that you can see. Yeah, now this is a protein 6CM4, and it is a D2 dopamine receptor which is bound to a drug which is called as risperidone. So risperidone is the drug. So what we will do is we will just scroll down and we will see what are the components does it have. Okay, so if you just see over here, it has, this protein has 1, 2 and 3 different ligands. Okay, and the main drug is this one. So this is the main drug. Okay, PEG and OLA are not required. They are basically used for the crystallization process. So they are not the actual ligands for this protein, but the actual inhibitor that we are looking for is this. Okay, risperidone. Okay, so this is the protein that we have. The quality of the protein, you can see it from this box which is over here, and you can see all the parameters. Most of the parameters are falling in this blue region. If the parameters are falling in this red region, then the protein quality is not good. Another thing that you need to do is the resolution. Okay, but anyways, we will go and we will simply download this file 6CM4. So to do this, what we have to do is we have to go to this download files and we have to click on this PDB format. So you just go to download PDB format and it will be downloaded, okay, as it has been shown. So where it will be downloaded, I will again minimize this. I'll go to this files option, and inside this we are in the home folder, and in the home folder it has been downloaded into this download folder. Okay, so let me just make it like this, and for docking purpose I want the work to be organized in a particular way. And why? Because it will be very easier for you to do it. So you just follow what I'm trying to do and you will get the gist of it. Okay, so I will create a new folder, and I will rename this folder again as 6CM4 simply, and press enter. So this is the folder that I have created. In this folder I will create I will create a new folder which is say protein_files. Okay, so we have desktop. On desktop we have this created a new folder which is also appearing over here, 6CM4, that is 6CM4. I will press onto this and there is a protein files, and within this protein files I will put this 6CM4. Okay, so this is the first thing that we need to do. We have to download the protein, right? The next thing that we need to do is to open this file in Chimera. So for that we will open Chimera from here. So if you just see, this is Chimera has opened. I will just make it a little big so that you can see properly. So now to open this 6CM4 protein, we have to go to files, this files tab. You can press it as open, and then you need to go to the desktop. On the desktop we have created a folder which is 6CM4. Inside 6CM4 we have created a folder which is a protein files. I will click onto this, and as soon as I click on this, my protein will appear over here, 6CM4. I will press it and I will press on open. So this is how the protein basically looks. Okay, so I will just make it as a full screen. Okay, and this is how your protein looks. Okay, so now first of all we have to perform docking, right? So what we shall do is that we have to first identify the coordinates of the ligand. Okay, so first step, very important step, is to remove unwanted ligands. Okay, so if I go to select and then the residue and then First of all, I will select PEG because it is polyethylene glycol, it is not the ligand. So I will select those. As soon as the PEGs will be selected, it will have this green border around itself. So I want to delete this. So the next thing that I will do is I will go to actions. Okay, then I will just hover my cursor over this atoms and bonds. I will scroll down and I will delete it. So I have deleted the PEG. Okay, so PEG I have deleted, right? Then I will go to select. Again I will go to residues. Okay, and then I will click on this OLA. As we have seen earlier, OLA is what? It is oleic acid. It is also not the actual ligand that we are looking for. Even if you see, it is not falling inside the active site. So I will just go to actions, hover my cursor over atoms and bonds, and then I will delete it. So I have deleted this part. Then again I will go to select, I will go to residue, and I will delete the water molecules. If you just see, these are the water molecules over here. So I will go to actions, atoms and bonds, and again I will delete. So I have deleted the water molecules as well. Okay, so here it is. Now let us see where the ligand is and where the active site is. So I will just go to my this actions. I will go to this select, I will go to this residue, and this 8Nu is my actual ligand that I am looking for, which is this one. So I will change the color of this ligand so that we can easily identify the ligand. So I will go to actions. Once I have selected the ligand, I will go to actions, I will change the color to red. Okay, so this is the red ligand. Okay, and then I will unselect. So I will do the option, go to select and clear selection. So this is what it is. Okay, so this is your entire protein. It is something like this, and where your ligand is, this is the active site, right? So this is the active site. So first of all, what I will do is I will save this protein in the same folder. So I will go to file and I will save it with the help of this option called as save PDB. Okay, so the same protein files along with the CMD, I will say protein underscore with underscore ligand. So like this, I have just saved it. So just if I minimize this and if I see the folder that we are working on, could you see this new entry has come over here? It just appeared over here because we have saved this protein, right? So now let me again open the Chimera. So I have opened Chimera once again, right? So this is what it is. Now the next thing that we need to do is to identify the coordinates of this active site, right? So we are supposed to now do and identify the exact location where this ligand is located. Okay, and we are going to give this location for docking in future, right? So we will go to this option which is called as tools. Okay, and then we will just scroll down a little and there is an option which is called as surface binding analysis. So you just go to surface binding analysis, scroll down, and there is an option which is called as Autodoc Vina. So you just press over it. Okay, for now you do nothing, don't do any changes over here. Just there you could see these boxes, you just put your cursor over there and put any random number. For now I am just putting a number like 5, tab 5, tab 5, tab 5, tab 5, tab 5. So I have made this. Okay, this any random number you can give, no problem. Okay, just put a tick mark on this resize search volume using, so I will just put a tick mark over here, and then I am using my mouse, which is a 3-button mouse, the normal mouse that we use, a desktop mouse. So I will go and I will go to control button 3. I will just explain why this is very important. And once we have done this, and where your cursor is blinking, just put a tab. Okay, and what you will observe is that you will have a box which is over here, a small box. This box is called as a grid box. Okay, so now let me open this fellow over here. Okay, now it says if you want to change the size of this box, you have to press control button 3. So what I will do is I will press control and then right click and I will just pull it out. Okay, then again I will press control and then I will pull the box like this. Okay, I will just rotate my protein a little. Again, I will now press Control, and then I will pull the box like this. Okay, again I will press Control, I will pull the button with the help of a right click. Okay, so like this, what I'm doing is I'm trying to create the grid box like this. Okay, so I have created my I'm just creating the grid box around the ligand in such a way that the entire ligand fix or occupies the space inside this grid box. Okay, so this is what it is. So now let me so yes, this is the active site, so I will control and I will do the so now this might be a very difficult at a first glance, but now you need to understand one very simple thing: how to increase or decrease the size of this box. uh, okay, could you see the walls? So can I say that this is a wall of this box? Okay, so here when I want to increase or decrease the size, I will press Control, and with the help of a right click I will just pull it inside or pull it outside. Okay, so like this. Okay, so this is what you need to do. With couple of trials you will be able to do this easily. Yeah, so this is the box. As soon as I change the size of this box, something will happen over here. If you just see, the orientation of this have the numbers that I have originally kept has changed. If you just see this. Okay, so what we will do is we will keep this, we will write it somewhere, or you can take a screenshot of this. Yes, so you can write it simply with the help of a pen or a paper. Okay, you can just to save these coordinates in a notepad file, what you can do is a notepad or any kind of just writing pad, you just click on this open terminal. Okay, so we have in this folder protein files, and you just type GEDIT. Okay, and you will get an untitled document which is something like this. Okay, so what you do is you just type these numbers over here. So I will write it first, then the second number. Okay, and this is the third number. Okay, so basically these three numbers are x, y and z coordinates. Okay, so x, y and z coordinates, I will just zoom a little so you can see. Anyways, okay, so these are x, y and z coordinates. Okay, you press enter and then you give the size. So this is the size of the box on the x-axis, size of the box on the y-axis, and then size of the box on the z-axis. Okay, so x, y, z axis. So above one are the coordinates. Okay, so the coordinates, and the bottom one is the size. Okay, so the size. Okay, and then what I will do is I will save this file, and these coordinates are specific to this protein only. So if you are taking any other protein, then you have to identify its coordinates in the identical manner. Okay, so I will just save it. Okay, so I will save this file onto the desktop. Okay, I will just go to this folder where we're working, and in the protein files I will just say coordinates. Okay, and I will just save it. Oh, I'm so sorry. Okay, and in this, and I will just save a press button. Okay, so I'll close this, and I will close this terminal as well. So now if you just see in the protein file, we have this coordinate as well. So we have written the coordinates. Okay, now what we need to do is we have to again open the Chimera, and this is what we had done till now so far. So you just close everything. Okay, so I will just close this. Okay, and I will simply close the session. So I've closed everything. Okay, so till now what we downloaded the protein, which is 6CM4, and then we removed the unwanted ligands or unwanted heteroatoms. Okay, and we kept only the ligand, identified the actual coordinates of the ligand, created the grid box around it, and the coordinates of the grid box that we will be using for docking is this one in this file, which is coordinates file. So I will close this. Okay, so now we will prepare this protein for docking. Okay, so the next step is to prepare this protein for docking. So again I will open Chimera from scratch, go to files, go to open, and you open this protein with ligand file and you just open it. Okay, so we have this protein and which is ligand which is attached over here. The first thing that we need to do is to remove this ligand, right? So the first thing that we will do is go to select residue, click on this residue. So this is the residue that we have. Okay, go to actions, atoms and bond, and then press delete. So we have deleted the ligand, right? And then we will save this file as save pdb, and we will just give the name protein underscore naked, because this protein does not have anything inside. Okay, I will just press on save. Okay, I'll just close session. So I've again right now I have created a protein which is a naked protein. Okay, so yeah, so the naked protein we have, right? So again we will open Chimera, and now this time we will open the naked protein. So open naked protein, we will open this. Okay, and now we will prepare this protein for docking. Okay, so you just go to tools, surface binding analysis. Okay, and then there is an option which says dock prep. Okay, tools, surface binding analysis, and a dock prep. Now you just need to understand one thing. You have to press on tools and you simply need to hover your cursor on this option. There is no need to click over here, and just move the cursor on the right hand side and just scroll down and just move down and select the option dock prep. Okay, so this is what we have. Okay, so these are the default things. For this probably we don't need to do this incomplete side chains. I don't think that is incomplete side chains, but just for the sake we will not change for this time any default options. So I will just make sure that everything is as it is. Okay, we don't have any non-complex ions, we have already removed it. Okay, so important thing that you need to remember is that the last option, write a mol to file, has to be there. If you uncheck this, then the file that has been created will not be used for docking. So you have to keep this small tick mark over here, and you simply press OK, and whatever changes is happening to this protein will be shown at the bottom of the screen over here. Okay, so it is basically trying to fill the side chains with the help of the Denbark library. So it is retrieving some information. Okay, so we'll just wait for a few seconds. Okay, so whatever changes is happening, whatever the processes that has been happening in the background has been shown over here at the bottom, right? You can keep this minimized or you can keep it as small, doesn't matter. Okay, wherever we, yeah, okay, so here we are. Right now it is trying to add hydrogens. I have just screwed up a little. Okay, so right now it is adding hydrogens. Okay, then assign charges to the dock prep. You just go to guest tiger. Okay, and do OK. Okay, and you just need to save this as protein underscore prepped, because we have prepared the protein. So that's it. Okay, so we have prepared this protein for docking. Okay, so what you can do is you can again close the session, right? I will once again show you how you can do the entire thing. So what you do is you go to file, you go to open, you then open the okay, just a second, I'll just go over here. I will just okay, so now the step that we are going to do is to prepare the naked protein that we just created for docking. So first of all we will open the naked protein that we created. So the protein naked, I just press on open. So the naked protein is over here. So now we need to prepare this protein or minimize this protein for docking. So for that you just go to tools, just hover your cursor over this option which says surface binding analysis, move it on the right, and then there will be an option which says the doc prep. So you just press on this doc prep option. Okay, now keep everything as it is. If you want to fill the side chains, okay, then you can use this option, otherwise you don't use this option. Okay, so now just keep this option turned on as it is. But for this protein I don't think that there is a need to fill the side chains because our active site is appropriate. Then very important thing over here is that you should have this option, write mol to file as ticked on. Okay, so you have to keep this option on always, because for the docking we require mol to files, right? And I will just press on OK. So now whatever the changes is happening, whatever the background processes that is happening for this protein, it will be appearing at the bottom, if you can see. You just wait for a few seconds for the process to be done. Okay, so now we have reached to a stage where it says adding hydrogens, and you just need to do one OK click. Okay, so it is saying it is trying to add hydrogens, so let it add. So now depending on the size of the protein it will take time, so this steps does not take much time, it happens very quickly, and you have to do this step only once for entire protein. Okay, so the next step is to assign charges. So we will use this Gesteiger, or you can also use AM1 BCC, but at times there is an error when you use this, so I will recommend to use this Gesteiger option, and I will just press on OK. So now it says nothing has been shown at the bottom, means the doc prep is done, and over here I will give the name it as protein prepared, and I will save it. Okay, so I will save this file as protein prepared, and I will just click on save. Okay, so now if you just see on the screen, if I minimize this, and if you just see this option, if you just see this folder, you will see that you have this mol to file appeared over here. Okay, so yes, we have done all the things that is required to prepare a protein. Okay, so this is done. So now the next step that we need to do is to download the ligand and prepare the ligand, right? So we will just go to this page, and it says Resperidon. So we need to download this ligand, so I will just copy this name. In the new tab I will just go to PUBCHEM PubChem. I will just type PubChem over here, it will take me to this library PubChem. First option, you just click OK. Okay, so now you will get this page, and on this page you just paste the name of the drug that you have just shown. So Resperidon, I will just click on this. Okay, Resperidon, so this is the drug, so I will just click over it. Resperidon, so yes, this is the drug. Now what we need to do is we need to download this structure. So on the right hand side, if you just see, there is a button of download, so just click over it and make sure you download a single file, which is an SDF file, which is a 3D conformer, and I will just press on save. Okay, so now it has been downloaded in the folder which is the download folder. Okay, so what we do is create a new folder and give the name Resperidon and create. So we have created the folder for ligand. Okay, and we also have the okay, so we also have this folder open. I will close it. I will again go to this home folder, and in this home folder under downloads you have this 3D conformer which we just downloaded. So I will just copy it from here or cut it from here, go on to the desktop folder which is over here, Resperidon, and you paste it over here, right? So close everything. Okay, so we have a folder, inside we have all the prepared protein files, and now we also have the reference drug over here, okay, which is a Resperidon, right? So now I recommend that suppose if you have 2 or 3 more ligands, you create more number of folders over here, and protein files you just need to create it once for one protein, right? So risperidone is a drug. We have downloaded it. I will close this folder, and now we will again open Chimera. So I will close the session, and now we have to prepare the ligand that we have just downloaded. We have to prepare the drug or a ligand, whatever you want to call. So for that, you go to files, go to open, and now there is a new folder that we have created, that is a risperidone. You click over it and click on the downloaded file, and you just press open. So you have this ligand opened over here. Okay, you carefully see, this is the ligand which we just downloaded few seconds back. Okay, so now we have to prepare this ligand for docking. So for that, you just go to tools, okay, press it once, and then you just hover your cursor over the option which says structure editing. Move your cursor on the right, and then you find an option which says minimize structures. So you press on this minimize structure option like this. Okay, so a window will open. These are the default settings, so I will use the default settings for now. To minimize the structure, I will just press on minimize. Okay, and here also you need to make sure that you are doing the tick mark at the mol2 file. We need mol2 files for docking, so I have done a tick mark, write mol2 files over here, and simply what I will do is I will say okay. Again, for adding hydrogens, I will say okay. Again, I will use Gestiger because I prefer Gestiger somehow. If you wish, you can also try AM1 BCC, no problem. Press OK. Again, net charges. For net charges, again press OK. And if you just see, you have the minimized risperidone. Okay, so I will just say res PERIDONE underscore minimized. Okay, make sure that this tick mark is there, mol2 suffix, and I will press save. Once I have saved it, I will close the session. Okay, now what you need to do is, the next thing that you need to do is, you just check your folders, the working folders, press on risperidone. Now you need to have two. One is the minimized and one is the SDF file. You don't need this file anymore, so you can delete it. If you want to keep it over here, no problem. We will just keep it for now. Now you just go back on the protein files and you just copy the mol2 file that you just created. So mol2 file you just created previously, you just copy it. So I will just Control C or just copy it, go back, and in this folder you press it. So right now you have two files with the mol2 format. Okay, so mol2 and mol2, both this. Okay, very nice. So till now everything is going smooth. So the next step that we need to do is, again we need to open Chimera, and now in this step we have to open both the mol2 files that we created, one for protein and one for ligand. So go to files, go to this open option. Okay, and in this ligand folder there are two mol2 files. If you just see, click on the first one, press Control button, and then also click on the second one. So you are selecting both the files, and you just press, both the files are selected, and you just press open. So now if you just carefully see, your ligand is somewhere else, your protein is over here. Okay, and now we need to do the step of docking. Okay, so let it be over here, no problem. For docking, we just need to go to tools. Okay, and then we need to move across surface binding analysis, and then we need to select this option again, Autodoc Vina. So this is what we have over here. Now we will start from the top. Output file. So where you want your output files to be, it has to be the ligand folder. So I will just go to browse and make sure that whatever I am doing, I will select this ligand folder, which is risperidone, and I will simply type docking. Okay, because this is the docking output files that we are interested in. So risperidone folder will create new files with docking. I will press on set output location. Now this is again a very important step. You have to choose the receptor and you have to choose the ligand. Okay, so protein, naked protein is appropriately selected, and for the ligand you keep the mouse left button clicked and you just hover it over 5073 because that is the risperidone. Okay, and now you need to mention the numbers that you previously mentioned. Okay, so for that what we will do is what we'll do is we'll open this folder and then we will just go to desktop. Okay, and protein files, and in this protein file we had previously created this coordinate file, so I will just open it once. I will close this folder. We have this coordinate files open over here, and you just need to mention the same coordinates. So it says even if it is say like okay, so let us say 10.37 is good enough. 5.60 minus 5.36, 21.4, it's okay. 20.6, it's okay. It's 25.7. Okay, so we have copied or we have mentioned the same numbers which we previously did for this protein. Close this folder, and now you will have the grid box at the exact same coordinates that we previously created. Now the next step is this executable location. So here we need to search for the path. It says path. So which path we need? We need to give the path of Autodoc Vina. So you just go to this folder that we created previously, Bioinfo Softwares, and then go to this folders, Autodoc Vina, again go to this bin, and you need to give this Vina. Okay, so it is home, Bioinfo, Autodoc Vina, and bin. Okay, so you remember this. Okay, so I'm closing this for now. So you just go to browse, just go back, you go to home, go to the username, and then scroll down. You will find this option which is Bioinfo Softwares. Go to this folders, go to this folder Autodoc Vina. Inside that you go to bin, and then you will ultimately find this Vina. Click on it and then say open. That's it. So you have done all the necessary steps. Okay, there are few other parameters that you can choose for the docking. Okay, so you just keep all this as it is, keep it as default. Ligand option, keep it as default. Advanced option, so here it will ask how many probable positions you need, how many poses you need. So we have kept it as 9. Okay, keep everything as default, and executable location you keep where you have opened the folder of Vina. Okay, and then you just press on OK. That's it. So when your docking has been done, see what is happening at the bottom. It is trying and to create new files, and it is the status says running, means the docking is occurring, the docking is happening at the background. Algorithms are doing its own job at the background, and we will come up with the results soon. I will wait for 10 seconds more. So yes, our results have appeared over here. Okay, so if you just see this, just forget about it. Once you get this dialog box open, means your docking is successfully done, right? So for now it is creating a lot of confusion for you because you can see 2 ligands over here. So I would recommend close everything, close session. So close session, you minimize Chimera, and now let us see what has happened to the folders that we created. Okay, so within the risperidone folder, if you carefully see, you can see starting from 1, 2, 3, 4, 5, 6 new files being created on its own when the docking is performed. Okay, if you are not creating these 6 files, means you have not performed docking properly. Okay, and the most important file out of this all is that docking.pdbqt, which has only one full stop. Okay, in all the others, if you just see, there are two full stops over here, two full stops over here. In this again there are two full stops, two full stops. Okay, so in only two of these files out of 6 there is only one full stop, docking.conf and docking.pdbqt. So we are interested in this docking.pdbqt file. Okay, so our docking is done successfully. I will close this folder. I will, to check how the docking is done, what we will do is we will open Chimera, and I will just open the folders on desktop which has proteins inside. So I will just open this, and I first of all I will open the protein files, and I will first open the file which says protein with ligand. So protein with ligand file I will open. So if you just see carefully, we have the original protein and the original ligand which was there, which we downloaded from PDB. Okay, so this is the original protein. Okay, so I will just go to select, go to residue and select the residue and change its color to red. Okay, so this is the original ligand which was there in the co-crystallized ligand, we can say, for the protein that we downloaded, right? So the question is, the docking we did, how accurate was that docking? Was it as good as the one which is co-crystallized or not? Okay, so for that what we need to do is, this is the original ligand. So first of all I will do the clear selection, and now we have to open the docking.pdbqt file. And there is a tricky way to open this file. You cannot simply go and open the docking file from here, and you cannot open it from docking.pdb. This will not work. So if you just see, it will show an error. Okay, it is showing an error, so I will just do cancel. The correct way to open the docking file, the docking output file rather I would say, is to go to tools, go to surface binding analysis, and then you hover down to the option which says view doc. You go to this view doc and press over it. You select the risperidone and you select docking.pdbqt file with a single full stop. Okay, single full stop, and then you press open. Okay, yes, and now if you just carefully see, on this window, these are the docking scores. So docking score is minus 12.6. It is very good. The RMSD is 0. So lesser the RMSD, better it is. So the first pose that you see, okay, is the first one. Okay, and if you carefully zoom it a little, okay, see how appropriately it is superimposing to the original ligand, okay, at the active site. So this, I assume it is the active site. So here the original ligand and the dock ligand is showing the identical orientation. Okay, this is the opening part of the cavity, so there might be slight variations over here, but doesn't matter. The actual binding seems to be appropriate over here. And if I just open this window again, if I click on the next one, okay, it shows me the second pose. So all these options that you get over here, minus 12.6 or minus 12.2, minus 11.9, all these are called different poses. Okay, so rather I would say this is the first pose, this is the second pose, okay, this is the third pose, this is the fourth pose, fifth, sixth, seventh, eighth, and 9. So these are 9 different poses predicted by the docking algorithm, which is Autodoc Vina, and the first one is considered to be the best one. Why? Because it has the maximum score, means more negative the score, more better it is. RMSD more closer to 0, it is considered to be good. Okay, so the first pose and the second pose are very identical if you just carefully see. Okay, so the next step what we need to do is we have to save this file. We have to save the file. Okay, so we will close everything. So close session. Okay, but now this time what we will do is we will open the naked protein. So you go to file, go to open. In the protein files you open the naked protein. Okay, so you have opened the naked protein like this. You click on open. So we have opened the naked protein which does not have any ligand. Okay, Into this, we will go to tools, surface binding analysis, and then we will click on the option view doc, and we will go to the ligand folder, which is risperidone, and then we will open the docking.pdbqt file. So this is the way to open the docking.pdbqt file from Chimera. Okay, so open. So yes, we have the protein and we have this ligand which is over here. So now what if we want to save the protein and the ligand into a single PDB file? That is the next question. Okay, so we need to remember there are 9 poses: 1, 2, 3, 4, 5, 6, 7, 8 and 9. So technically we can save all the 9 different PDBs with a protein. Okay, so that is possible. So let this be open. In order to save this ligand and this protein together, or the docked ligand and protein together, you just go to files, and then there is an option which says save PDB. Okay, so as soon as you have this, you just say and write pose 1. Okay, you just type pose 1, and to save it as a single file, you just need to first press on the just zoom it a little. First click on the protein and then press the control button, keep the control button pressed, and then you click on 1.1. now this 1.1 means the first pose. Okay, then when both of these are selected, it will be slightly dark grayer than the other gray that you see at the bottom. So what you do is, once both of these two are selected, okay, you need to change this save multiple models, keep it pressed, keep the cursor pressed, and then choose a single file. So you need to so what will this do is that it will save both of these, the protein and the first pose, as a single file, and we have given the name pose 1, and you just press on save. So we have saved the first pose. Okay, the second pose was also considered to be really good. So what we will do is, again we will go to file, save PDB, and over here I will change the name pose 2. Make sure that you are in this same folder, which is risperidone. Okay, pose 2, press on the first protein and then press control and then click on 1.2. so now we have 2 files selected, protein and the second pose. It has to be a single file over here. You have to write pose 2 over here, and then you need to click on save. So if you just minimize this, if you open this, and if you just see risperidone, okay, you have this pose 1 and pose 2 over here. So this is your docking being completed. Okay, so I will just close this for a moment. Okay, so this is your docking being done. What you can do is, you can just write this score, or you can take a screenshot of this into a notepad or your Excel file, whatever you want to do. Okay, we will go to quit, go to file, we will close the session. So we have closed everything. Now let us check whether the poses that we created are being opened properly or not. So we'll go to risperidone. We are trying to open this file, so we will go to Chimera, go to file, go to open, and then click on the pose 1 that we select, and then press open. Okay, so yes, so this is what it is. Okay, so for instance, now you want to do the docking of the same protein once again with another ligand. Okay, another ligand, then you don't need to repeat the entire process. What you simply need to do is to create another folder over here. Like, I will create a new folder with a ligand name, so I will put a name ligand 2. Okay, and I will create a folder like this, which is a ligand 2 folder. Let's quickly do it. Ligand 2. So I will just go to the Google, and I will search for, say, dopamine D2 inhibitor. So we are doing it once again. So dopamine D2 inhibitors. So yeah, very nice. So this is a drug, clozapine or clozapine, whatever you want to call. I will just copy the name, go over here, search for this drug. Okay, so the drug is this one. You click on this. Okay, make sure you remember this ID, and then you press on download, save. So this will be saved in the download folder. So I will just press over here. So this is the file. I will cut it from here quickly, and then I will put it into a folder which is already open, which is a ligand 2, and I will press it and open and save it. Okay, I will rename this, and oh oops, okay, so I will rename this folder with the name of the ligand. Okay, so I will rename it. So we have a new ligand inside. We will repeat it very quickly so that you can get a gist of it. Okay, open file. We will open the new drug, clozapine. So we will open this. We will minimize this first of all. Go to tools, surface binding, structure editing, and minimize structure. Minimize. Write mol2 again, very important. You need to press mol2 over here. Okay, 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 and then you need to go to this folder. Okay, file, save mol2 into this folder, and oops, it took the old name, so I will just rename it. I'll just say clo minimized, and mol2 is there, and so I will save it. Okay, so if you just see, I will delete this because by default it created this file, so I will delete it. So now we have this minimized ligand file over here. You copy one file, which is the mol2 file, from the protein folder and put it into this folder. So we have two mol2 files as mentioned earlier. Very quickly I will open Chimera. I will do close session. I will open both the files. I will go to this folder, and I will select the both minimized and press open. So yes, I have this over here, and then I will go to tools, surface binding analysis, Autodoc Vina. Make sure you select these two properly. Naked protein is this one, and output file you need to go to browse, select the ligand name, and inside you just type docking, docking, set output location. You type those numbers over here. I think where are those numbers? Okay, so just go to protein files, coordinates, and you just open Chimera as well. Okay, so you just type these numbers, say 10.37, 5.60, minus 5.36, 21.4, 20.62, 25.73. Okay, close this. Make sure the boxes, the grid box is properly being created around the ligand. Okay, make sure the executable location is what you had previously selected, and then simply press on OK. You will see the changes occurring at the bottom of the screen over here. It also says finished. It says running, so it is running. And while it is running, if you just see the folder, see the new files are being created. Okay, as soon as, but right now 1, 2, 3, 4, and 5, only 5 files are created, so the process has been done. As soon as you get this window, all the 6 files would have been created in this folder. Okay, so I will just open this. Yes, so we have this ligand in the active site. I will close the session. I will first of all open the naked file because I want to save the file. So I will just go to protein files, and I will open the naked protein. So naked protein is over here, and then I will go to tools to open PDBQT file. So go to tools, structure finding analysis, and then you go to view doc. In view doc you select the ligand folder, and then you choose the PDBQT file with a single full stop, that is docking.pdbqt, and you open it. Okay, docking score is -8, so it is not as good as the previous ligand, but okay, anyways, so this is what it is. I will just close this window for a while, and I will save uh, this complex as a single PDB. So I will go to file, save PDB. I will select the folder first of all. I will select it as pose1, select the protein, press Ctrl button, and then click on the first pose1, and then I will save it. Okay, so I have saved it. I will just close the session. I will just minimize everything, and then I will see whether the pose1 is been created or not. So if you just see in this folder, pose1 is properly been formed in the PDB format. Now just open this pose1 and check whether the docking has been done properly or not. Yes, so this has been done absolutely well. Okay, so this was all about the docking that I wanted to explain you today. One more thing, if you want to see the cavity, what you can do is you can just select the chain. So I will select the chain. Okay, and then I will go to presets. I'll go to tools. I will go to actions. I will go to surface, and on surface I will put show. So this will show you the protein like this, and you can see your ligand inside over here. Okay, so if you just see your ligand like this inside, okay, inside the cavity, select chain, and if you just select this ligand, and then you go to tools, actions, go to colors, and do it as red so that you can easily visualize it. Okay, so this is what it is. So I hope this goes well, and this was all about the docking that I taught you today. In the next session I will explain you how you can analyze the complex. Okay, so if you just see the papers, and in the research articles you have the images like this, okay, where they are showing how you can analyze the interaction that is taking place in the active site of a protein, right? So this is what we did, risperidone and DRD2. So this is something that we just did in our tutorial. In the next session I will explain you how you can create these diagrams and how you can see where exactly in the active site your ligand is interacting with which exact amino acids. Okay, so that we will do it in the next session. Okay, so I believe you understood it pretty well. Yeah.